You're listening to Tim McKinney of ITW Evercoat. Evercoat, the brand trusted by more shops for automotive, commercial, and marine repairs than any others for almost 70 years. Bringing you continued innovations like Light Speed Repair System to streamline and improve repairs at the speed of light. Optex Filler with color-changing technology and Optex Super Build with a built-in guide coat. And now, here's Tim.
Let's talk about some of the problems we've seen and heard about over the years. This is one of the first areas I get questions about, not very often, but it does tend to come up. And this is where the filler or the putty, typically the filler, and I'll explain why it's less on the putty in a little bit, will not properly cure, or it's going to be sticky or it's going to be soft. Now, there can be a variety of things that could have actually caused this. The first one is it may not have been catalyzed properly or at all. I've seen that happen. Folks aren't aware sometimes if they're new to using products like this, that this is the catalyst, this little tube to go to the gallon. They have to put some of it in there. Or they may not have put in enough. So that could be one of the other issues that they have with it. So it may not have been fully mixed in. They put in enough, but they didn't fully mix it. And that's really common if you use a white hardener with a product like this, because the white hardener, once you fold it over, it kind of disappears. So you think you've got it fully incorporated, but it's not. The working environment wasn't conducive. I hear this question all the time, and you're going to hear me probably through this presentation talk about some numbers, meaning it was probably below 75 degrees. We don't like to see our products being used below 60 because it's really hard for these to create that exothermic energy to cure properly. Likewise, using them above, say, 85 degrees or 90 degrees, most people tend to want to cut back on the hardener. And so when it's not really used in a temperature that's going to be conducive to work with, that's where some of the problems start to come up. So I always say, try to warm the surface to get it close to that temperature range. And if it's too high, try to lower the temperature to get it where it's going to work for you a little bit better. We're going to talk about some ways to do that as well. The filler or putty was applied over a freshly applied primer surface. Now, I want to talk a little bit about the primer surfaces a little bit later on, but think about some of the chemistries that we work with in the shop. Everything that we're doing for the collision repair or the restoration starts off as a paste, a liquid, a gel, and it's going to go to a solid stage. If it's still curing and you put something over top of it that maybe cures faster, that's where you're going to start running into some of the problems. You really don't want to be putting it over freshly applied primers as the solvents are trying to come out and it's curing, and you don't want to apply it over an incompatible primer. And we'll talk about those. The filler was applied over an acidic coating, or there was some kind of acidic residue left on the surface. Now that really comes into play for self-etch primers. My colleague and I were doing some research the other day, looking up some things, and there were some folks on the internet talking about applying a self-etch primer and then putting a polyester over top of it. It's not really going to work, and here's why. Acids will inhibit the curing process for a polyester. So the top of it, where it's not touching on top of the acid, it's going to cure just fine. But down in the bottom, where it's touching, down in at that feather edge, once you start to sand it, it rolls back, it rolls back, and it rolls back. It may even roll back to the point you sand all the material out, because what makes the self-etch work makes the polyester filler not work. So don't put it over a self-etch primer. We'll talk about epoxies in a little bit. The hardener was cut back too much, or maybe the hardener's just gotten old. It's lost its strength. I go into some scenarios and I see where the tube of hardener looks like this, and there's no hardener cap around at all. This is a magical device called a lid. Put this on. It keeps all the solvents and the chemicals in this tube to make sure it's going to remain at full potency. If you have a tube that's not at full strength and you use it, the color may look correct, but it may not have enough chemical energy, because you got one part of this to 50 parts of this to cure the material. So if it didn't work properly, that's probably a good sign that maybe you got some old hardener. I'll show you how to check in a second. So if you did have this particular scenario, what's going on with it? Well, here's some of the ways you're going to need to fix it. First off, if it didn't fully cure, you're going to have to remove that material. It's not going to magically cure. It's not going to cure by putting heat onto it. If there wasn't enough chemical energy to get it to fully cycle off, the word we say is polymerize. We're taking a monomer and we're going to have it mixed in with the catalyst to create a polymer. If we didn't put enough energy in to do that with the chemicals, it's never going to be fully polymerized. It's never going to fully cure. Just because the material hardens doesn't always mean that it is fully cured. So remember that. If it's partially cured, well, you may have to mechanically take it off. I've even seen situations where it wasn't cured at all, and they're actually just using one of these to scrape the material off, then go back in and reapply. What you don't want to do is apply another coat over top of it. I've heard of this reference before where they call it hot batching. That's where you mix up another material to go over top of the first one. The second one's got more catalyst. The first one didn't have enough catalyst. Trust me, they're not going to go on top of each other and just magically commingle and mix each other up. Instead of hot batching, you're just going to create a hot mess. So don't do that. How do you fix it? How do you avoid even doing this? Well, here's what you want to do. Mix smaller amounts. If you mix smaller amounts, you're going to have much better control. Usually I see some of the inexperienced technicians or newer folks working with these products not really knowing how to use it. I always say test small, work big. Test a small amount, get a feel for the product before you go right diving into the repair process and see how the materials work. Work at a temperature that's as close as possible to around 70 to 75. If you look at any of the tech data sheets, the information on the back of the labels, we're going to have ranges of our products somewhere between those as far as the work times. So if you're working in that temperature range and you're not seeing a close number to that, that's an indicator that you might be over or under catalyzing the material just a little bit. We talked about the self-etch primers. Avoid applying the polyesters over a self-etch primer or some of the fresh primers. Now, talking about self-etch and also the epoxy primer, I literally just had this conversation with a good buddy of mine Friday night for a scenario. He wanted to know if our products could go over top of an epoxy primer. And I said, well, they could go over an epoxy primer, but you need to look to see, can that particular epoxy primer have a polyester put over top of it? They're typically going to have that information on one of their technical data sheets. Some epoxy primers will say do not use with a polyester over top of it. So if it says that, they've probably tested it. Don't use it. If you don't have any guidelines on that, if it's kind of vague, we actually have, if you go to evercoat.com, if you look into our technical resources for a tech tip, there is one in there that says polyester over an epoxy. Download that, have that available for you. The gist of it is going to say this. Apply the epoxy primer, let it sit for around 24 to 48 hours, lightly scuff it, and then apply the product over top of it. And that's going to be fine for a polyester primer, a polyester filler, or a polyester putty. If you're getting into a fiber reinforced product, I actually like to see that bonding onto the surface itself, onto the substrate. So if you're going to actually need to put a fiber reinforced product down, sand the epoxy off, apply the product. And then when you're done with the repair, come back and then put the epoxy on if you want to seal the whole thing off. That can be done. You can put it over the polyester. Next thing was making sure that you didn't cut back on the hardener too much. You want to make sure that you've got the right amount that's going to be in there and check to make sure it's not lost any of its strength. I'm going to show you here in a little bit how to read the batch codes on the products and on the hardener. Because like I said, you got one part of this activating 50 parts of the filler. So you want to make sure that this is maximum strength. This is going to do everything you need to do. All right, so we said make sure that it's not applied, the selected filler, and prepare the area to be filled with the selected product. And then, well, actually, I backed up. We got a little ahead of ourselves. Sorry about that. So the next problem we have, the filler's cracked. All right, so when the filler has dried out, it's become unstable. And what that will cause is the solvents that are in there to leach out, and that's why the product cracks. Whenever we hear that the body filler is cracking, we can always look to see that it has been under catalyzed. If you want to see how to properly catalyze the product and you have access to a very high quality scale, you're in a body shop, go to the paint side. Mix up 100 grams of the product to 2 grams of the cream hardener, or mix up 50 grams to 1 gram, and you'll get a visual cue for what the color is supposed to look like. That's really going to help you to make sure that when you mix it from that point on, you're always mixing to that continuous color. So what happens is the repair has absorbed some solvent because it wasn't fully polymerized. When it's not fully locked up, there's little gaps in there where the solvent can get down into. And over time, those solvents are going to evaporate back out. And when they do, the product will actually pull away from itself on the surface and crack, just like a lake bed will do when it's drying out, because the material is doing just that. It's drying out. And once it's cracked, it can crack all the way down into the very substrate, and it can cause some rust to start down in there. So if you see you have a repair that's cracking, probably going to be under-catalyzed, or it could be that your catalyst has lost some strength and you didn't catalyze enough because you couldn't visually see that. Good friend of mine and I were actually having this conversation the other day, and he was asking about putting it over an epoxy primer because they had one come back that was cracked and it did actually start to have some corrosion underneath of it. Putting it over the epoxy could help the corrosion from starting to become into play. However, under-catalyzing it, putting it over an epoxy, it's still going to crack. It's not going to fix that. So if you're going to put it over an epoxy, still make sure that you're properly catalyzing it. The next thing is it wasn't a conducive temperature. Usually for that is it's too hot. When we hear about the cracking scenarios and we go back to when it was applied, odds are we find out that the product was applied in some of the warmer months, June, July, August, maybe even early part of September, depending on where it was applied and what part of the country. So make sure that you're not under-catalyzing it to give yourself extra work time. And again, I'm going to show you some tricks on being able to do that so you don't have to worry about under-catalyzing the products. And as I said, it's probably because the hardener was cut back way too much or the hardener's lost its strength. So how do you fix it? Well, if it's cracked, you're going to have to take that material out and redo the repair. It's a pain in the keister, but if it's already cracked, that's telling us that that area is under-catalyzed and the rest of the material is under-catalyzed as well. So you're going to need to mechanically remove that material and then reapply the product. That's the only way you're going to be able to take care of that. The ways to prevent it, as I said, properly mix the product up, mix it at a 50-to-1 ratio, mix smaller amounts. Instead of trying to do 2 repairs at once, slow down a little bit. Good friend of mine, if he's happened to be watching this, he used to always say in all those classes, and yes, I was listening to you, the hurrier I go, the behinder I get. Well, you know what? I've realized haste makes waste. That's what he was saying. By trying to rush through the process too much, sometimes we skip steps. Sometimes we have bad habits. So maybe slow down and do 1 repair at a time on a warmer day, or maybe do those repairs earlier in the day where it's not so hot. Which brings me to the next point. Try to work at a temperature range. It's going to be around 70 to 75 degrees Fahrenheit or 21 to 24 degrees Celsius. As I said, all of our tech data sheets and our product informations are given within those temperature ranges. Avoid putting it over freshly applied primer. Again, some of those solvents could leach up into the product while it's curing and continue to leach out. We don't want that to happen. And store the product in a cool, dry place with the lid on tight. The reason for that is oftentimes when I see where the lid's not properly applied on the can, the product starts to dry out. As it starts to dry out, the materials that are in it that create that chemical reaction so it fully cures to polymerize, they start drying out as well. So that could be part of the issue. So always make sure you put the lid on tight. Even if you are using it through the day before you leave at night, just give the lid a bump. Make sure it's sealed up pretty good and put the cap back on the hardener.